Okay, so let us write answers and solve few problems which were part of your homework. First problem was easy. All brackets getting factorized. The solution set is minus infinity to 1 union 3 to 4. In second problem, the last bracket is always positive. Therefore, we need not have to worry about it. First two brackets get factorized and it is same as earlier problem. Solution set is minus infinity 1 inclusive, 5 inclusive plus infinity. Third problem, we have denominator and repeat roots in the numerator. The solution set, if you make perfect square in the denominator, you can push them up and again draw the sketch, the solution set becomes this. Now, here we have done some calculations for solving this problem, which we should understand. Denominator should be perfect square, therefore multiplied by x plus 5. So practically you have x plus 5 in the numerator, x plus 8 raised to 4 is positive. So temporarily we are ignoring it, but x is equal to minus 1 minus 8 need to be considered. 1 minus x raised to 3 can be broken up in these two parts, and 1 minus x square is positive. So practically you will start with number to the left of minus 5, it is negative, go there. 5 is not part of the solution set because it is in the denominator, positive. You cut at 1, equality allowed, therefore x is equal to 1 allowed. Go down the x-axis, put any value between 1 to 1.5, 1 to 2, say 1.5, you get negative, so this is correct. 2 we are not allowed to put because it is in the denominator, and any point after 2 will continue giving us the LHS negative. You can cross check, this is 3 positive negative, so it will go down like this. So as per graph, if we want to write down the solution set, it will be minus 5 to 1. However, we cannot forget minus 8 because the moment we put x is equal to minus 8, LHS becomes 0 and 0 is equal to 0, which is true. So it is a part of solution set. However, I think this problem is going to be more interesting if the inequality is changed. Let me write down maybe 4 point additional problem. 4.5 x plus 8 bracket raised to 4 1 minus x raised to 3 upon x plus 5 x minus 2 bracket square is strictly less than 0. Is strictly less than 0. Now draw the graph and report the solution set. Majority of the work done is already available with you, so you should not take more time, but we have to be very careful in writing the final solution set. Give you a couple of minutes. Now the modification in this graph is for minus 8 to minus 8 because it is strict inequality, and at minus 8 the function becomes 0, LHS becomes 0, and it is not acceptable. Therefore, we have to sketch to the left of minus 8 also. So if all values of x are taken less than minus 8, the function is negative. So it enters like this, just minus 8 because at minus 8 the function becomes 0. It comes back again, continues to remain negative till 5, crosses 5, 5 not acceptable because it is in the denominator, becomes positive, crosses 1, 1 not acceptable because of strict inequality. 1 to 2 negative, 2 not acceptable because in the denominator, right? And again it continues to remain negative. So this is the correct graph for this, and therefore solution set is minus infinity minus 8 open union open minus infinity minus 8 comma minus 5 open union open 1 to uh, union to plus infinity. Okay. Any argument on this? There are four brackets. Or what we can say is, I mean, you can write it in this fashion also, minus 8 or something like that. But it is better to write like this because from left to right you are scanning and you are taking care of all values of x correctly. So, is this answer correct?
Yes, sir.
Now, this minus 8 would get you numbers minus 1 instead of plus 4 in exams. Because if we say that x plus 8 raised to 4 is always positive, so it will not matter. But then you are talking about negative inequality, less than 0 inequality. So definitely it matters. Because if x becomes minus 8, you get equality with 0. So therefore, this problem was easy. This is little difficult because you are forced to make an error, especially at point minus 8. Okay. Let me write down let us solve this. This is 1 upon 1 is plus x minus 3 less than or equal to 0. That makes it 1 plus x minus 3 into x minus 1 upon x minus 1 less than equal to 0. That makes it 1 plus x square minus 4x plus 3. Is that correct up to this point?
Yes, sir.
X minus 2 bracket square into x minus 1 should be less than equal to 0. Making complete square in the denominator, you get x minus 1 factor in the numerator and you are required to do less than. So x is equal to 1 has to be kept in mind. I am not acceptable. It is not acceptable. So critical points 1, 2. If you start to the left 0, if I put 0, minus 2 square is 4, minus 1 less than inequality, therefore it will enter like this. 1 I am not allowed to put, so I will continue with minus, hollow circle. If I put something between 1 to 2, 1.5, negative, square, positive, positive, hence it will go up. Is that right? Now, if I put 2, which is a possible way, equality, so I can darken this circle. And then if I put 3, this is positive, therefore it will continue to remain positive. Is that right? And therefore the solution set answer is minus infinity to 1 open. How many of you want to answer?
सर वन डार्क सर्कल पाहिजे ना लेस देन और इक्वल टू आहे
नाही
वन सबस्टिट्यूट केला की झिरो येईल
Undefined येईल वन
ओ
सबस्टिट्यूट
हा
केलं तर.
अच्छा अच्छा
Danger.
तर युनियन 2 यायला हवं अंतर
येस सर 2 पण यायला हवं.
2 पण एक पॉइंट आहे
2 पण यायला पाहिजे.
डार्क सर्कल आहे
Correct. Yes, I should have made it dark like this. Anyway, I am not wasting ink. Okay, so this is what is the solution set. Now I think there is a sixth problem, which is the last one. 6. So by now you must have understood that it is a very simple theory, but complicated problems can be created. And if you are not focused, if you are not concentrating well, and if you have not understood the concept well, there is every chance that you will commit a mistake. Unless and until you are extremely careful, you will not get correct answer. 6. This A wala kaitari problem. No? Ax is greater than 1 over x. Case 1. A is greater than 0. So if A is greater than 0, what I can do is ax minus 1 upon x is greater than 0. Makes it ax square minus 1 upon x greater than 0. Makes it a square minus 1 into x should be greater than 0. And x should not be equal to 0. So what do? I should factorize this eventually. So if I take a common, I get x square minus 1 upon a into x is greater than 0, which makes it a x plus 1 upon root a x minus 1 upon root a into x greater than 0. So we have got these factors now. It is a is positive. I think we should be able to deal with. Shall I write the solution set in this case? Aditya M is coming. Okay, so if this is my a is positive, so I can have this radical sign, and therefore my critical points are x is equal to 0, follow circle, it's not allowed. Then minus a is positive, so minus 1 upon root a plus 1 upon root a. This is my wavy curve. So if I start to the left of every bracket is going to be, let me write down this little differently so that I can visualize this better. X minus 0 is greater than 0. So to the left of minus 1 upon root a, everybody is negative. So the graph will enter like this. There is no question of equality. So everything is going to be hollow circle. And then this is linear. There is no repeat root. So it is going to go like this. Correct? And therefore solution set answer is, we want greater inequality. So open interval minus 1 upon root a. This is what? 0, comma 0, open, union, open, 1 upon root a, comma, plus. So if case 1 a is positive, this is the solution set. Case 2. A is less than 0. If a is less than 0, then up to which point we can go? Up to this point. So a into x square minus 1 upon a into x minus 0 should be greater than 0. Now a is negative, therefore this bracket is always positive for every value of x. Leading coefficient is negative, right? is as good as minus. Suppose we take a is equal to minus 1, then it is minus x. Minus x is going to be greater than 0, and therefore solution set for this is going to be all values greater than 0. Correct?
All values smaller than 0.
We have
Sir, inequality would flip after cancelling that a and x square minus 1 upon a.
equality काय?
सर
एक मिनिट
आपण
जरा.
a ला जर का
Minus 1
साईडला नेलं
x should be greater than 0, therefore x should be less than that. Correct. This is not correct. Minus infinity to a. Oh, sorry, not a, 0. Open, open. हा, अनिश आता काय बोलतोयस बोल.
काही नाही हेच म्हणत होतो सर.
Okay, ठीक आहे. So if a is less than 0, this is the solution set. And if case 3, if a is equal to 0. If a is equal to 0, LHS is 0. So we are solving 0 is greater than 1 upon x, which is x upon x square is less than 0, which is x less than 0. So answer is x less than 0. That is what is the answer. So same solution set. Minus infinity comma 0. We could have included it over here. Equality. बरोबर लिहिलं नाही सर. 0 असेल तर 0, LHS becomes 0, 1 upon x will be less than 0, therefore x. बरोबर. So that completes our discussion on homework. After a long time I have discussed problems, homework problems in the class. Almost I have forgotten how to discuss problems in the class. Okay? Okay. So now there are plenty of problems like this. Maybe if you want, I can give you some problems.
सर मला 4.5 मध्ये डाऊट आहे.
4.5 मध्ये डाऊट आहे. अरे काय डाऊट आहे बोला.
Sir, can you zoom out a bit?
Zoom in or zoom out? This is zoom out, I think. That is what you want?
हा.
Okay. 4.5. What is the problem? Is the solution set not correct?
So if we take x equals less than -8,
Yes.
मग त्याची व्हॅल्यू पॉझिटिव्ह येते. कारण x+8 आणि x-2 हे दोघेही म्हणजे ते दोन हे असणार ना, पॉझिटिव्हच राहणार कारण 2 चे पॉवर हे आहेत.
एकच मिनिट आपलं वरती काय चुकलंय ना. If we put एक मिनिट.
सर पॉझिटिव्ह अपॉन निगेटिव्ह येते.
हा सर बरोबर आहे.
बरोबर आहे. हाच सोल्युशन सेट करेक्ट आहे. सर 1 minus x would be positive, 1 minus x cube, and x plus 5 would be negative.
ओके ओके. हा
करेक्ट आहे, काही प्रॉब्लेम नाही. Have you understood?
येस.
Okay. Find all values of A. For which following equations as have real roots. One by one, I mean there are different problems. Uh, problem number 1, I, x square minus ax plus 36 is equal to 0. Find all values of a such that this quadratic equation has real roots. Resume recording. Increase the percentage to 56%. Okay. So discriminant of this delta should be greater than or equal to 0. What is delta? A square minus 4 times 36. 4 times 36 is 144. This is what we have been doing last 2-3 lectures. Equality, no denominator, all are dark circles. Leading coefficient positive, opening up. We want greater than inequality, so solution set minus infinity minus 12 closed union closed semi. Next, x square minus ax minus a is equal to 0. Same statement of the problem is same. Find all values of a such that this quadratic equation has real roots. Show me the answer. Okay, solution set of this is again discriminant greater than equal to 0. Discriminant is a square plus 4a greater than equal to 0. A minus 0, a minus 4 greater than equal to 0, minus 4, 0, equality, dark circle, leading coefficient positive, opening up. And solution set is minus infinity minus 4 closed, 0 closed, plus infinity. Third problem, x square minus ax plus a is equal to 0. Fourth problem, x square minus x minus a square is equal to 0. Fifth problem, x square minus x plus a square is equal to 0. I will solve all the 3 problems. You solve and keep your answers ready. Answers for these questions are solution set minus infinity 0 closed union closed 4 plus infinity. Solution set for this is minus infinity plus infinity. Every value of a is okay with us. Because discriminant is going to be always positive. Solution set for this is minus half comma half. Question number 8. find all values of a for which x square minus ax plus 4a plus 1 is equal to 0 has both roots positive. Give you sufficient time. Okay, let us start analyzing what do we want. Now, this is going to be very, very interesting and conceptual. So if you understand, you understand. I really do not know how to go about it. So we will go very systematically. Good part of this quadratic equation is that leading coefficient is 1. So we are sure that this quadratic equation has a graph which is opening up. Now both the roots positive. That means opening up a quadratic equation. Suppose this is y-axis, then your both the roots should be greater than 0. And it is said that both the roots are positive. Therefore, they can be equal, they can be distinct. Hence, first condition which we get directly, because we need roots and they are supposed to be positive, and we want both of them, both the roots. So, step by step, if we think, first condition that we get for satisfying the requirement of this problem is delta must be greater than or equal to 0. If delta is less than 0, then we will not get roots, which is not acceptable. So maybe this is our first condition that need to be satisfied. Now the moment we write our condition, we can get the relationship between a and 0. I mean LHS will be the quadratic in a. So what is discriminant? A square minus 4 into 4a plus 1 should be greater than or equal to 0. This quadratic equation will give you some solutions. Some solution set S1 is equal to. If we solve this, we will get it. So that is one part of the story. But is it sufficient? Because this is necessary. This is necessary, but not sufficient. And hence, we need to look at it, because leading coefficient positive, and if you want two roots, the graph can be like this, or graph can be like this. Now, you really do not know where the y-axis is, and therefore both the roots positive might not be taken care by only this. This will take care of both the roots available, right? And therefore, let us draw a couple of sketches where this is not acceptable. This is not acceptable, but this is acceptable. This is acceptable. Okay. So what are the differences between these graphs? Green graphs are acceptable, Blue graphs are not acceptable. Blue graphs are, and I mean, if your graphs are towards, this is absolutely not acceptable. This is also not acceptable, passing through origin. And another root negative. We want both the roots to be positive. So, if we consider, let alpha comma beta be the roots, then these coefficients talk to us. They tell us some story about the roots that this quadratic equation possesses. We have learned that. So if alpha plus beta are the roots and both positive, then okay, if both of them are positive, then alpha plus beta is going to be greater than 0 because both of them are positive. That is what is this fellow trying to tell us. So we can say that our second condition which we need to consider is, what do you mean by sum of the roots? Because that is the information available. Delta is the information available. Sum of the roots is the information available. Product of the roots is the information available. That is the only information available. We have to exhaust all the information which is available to us. So available information is sum of the roots. If both the roots are positive, can I make use of this information that sum of the roots is A? Yes. So how much is alpha plus beta? This implies alpha plus beta is opposite of A, opposite of A divided by 1, which is A must be greater than 0. Oh, this will provide me second solution set. We will find out. I mean, this is the solution set. It can happen that sum of the roots is greater than 0, but not necessary that both the roots are positive. If one root is minus 3 and another root is plus 4, then sum of the roots is positive, but both of them are not positive. Therefore, this is necessary condition, but might not be sufficient. This is necessary condition, but may not be sufficient. Necessary may not be sufficient. Therefore, we have to exhaust the third information which is given to us, which is product of the roots. If both the roots are positive, then product of the roots alpha beta is also going to be positive. This implies, what is alpha beta? 4a plus 1 is that right? This gives us solution set number 3. This should be satisfied, and this should be satisfied, and this should be satisfied. Let me write it down very carefully. This should be satisfied, and this should be satisfied, and this should be satisfied. Therefore, solutions, eventual solution set is going to be S1 should be satisfied, and S2 also should be satisfied, and means intersection. S2 should be satisfied, and S3 should be satisfied, and means intersection. So if you have these three solution sets, maybe we can plot it on real number line and then figure out what is the most common part of this real number line. That is the only available values of A, which will give us solution for this problem. Now this is first problem of this kind, theory of quadratic equation. So here these two solution sets are easily available. Let me write them. A is greater than 0, that is the solution set number 2. Its diagram is like this: 0, strict inequality, therefore all the points greater than 0. all the values greater than 0. Alright. This is another simple solution set. A is greater than minus 1 by 4. Oh, this is, this is okay. So 0 or minus 1 by 4, and A should be greater than that. Okay, this is the solution set. Of course, this solution set is a part of this solution set. So finally, eventually, at the moment between S2 and S3, S2 is winner. Very good. Now our job is to get S1. So let us do some calculations to get S1. S1 is A square minus 16A minus 4 should be greater than or equal to 0. So A is equal to 16 plus or minus under root 16 square minus plus 16 upon 2. This is the value of A if you solve the LHS using quadratic formula. Now can you tell me quickly what is this simplification? It is 8 plus
8 root 20.
root
Definitely.
68. Okay. So factorization of this is going to be A plus A minus 8 plus root 68 into A minus 8 minus root 68. This is the factorization of this is greater than or equal to 0. So what is the graph of this? Graph of this is real number line. So is coming. This is 8 minus root 68 is going to be smaller, and 8 plus root 68 is going to be bigger. So this is what it is, and equality allowed, therefore dark circle, equality allowed, therefore this. So solution set for S3, this is S3. So now we are supposed to take intersection, therefore we should put these three lines one to the other and find out which part of real number line is common between all the three. There is a little problem. This is gone because negative side, see 8 into 8 it's 64. So root 64 minus root 68. So this is definitely a negative number, and we are the S1. Sorry, this is S1. This is S1. S1 is saying either go to this negative number to the left or towards positive number of this. So we have 8 plus root 68 and 8 plus root 68, and what is that we have to compare? Eight plus root 68 is definitely going to be greater than 0. Therefore, 0 is greater than minus 1 upon 4. So do you see that 8 plus root 68 is towards the right, then 0, then minus 1 by 4. And left hand side solution set we have to ignore because it is not common. S3 says go to the right from here, S2 says go to the right from here, and S1 says go to the right from here. Only difference is inclusive of this. Therefore, final winner solution set is equal to closed interval 8 plus root 68 comma plus infinity. Write down the solution that is written on the board properly. Try to understand it. I am sure you must not have understood something which you should ask. Okay, small variation. Find all values of a for which the same quadratic equation has both roots negative. Okay, so I am sure you have understood that S1 will continue to remain same. S3 will continue to remain same for this negative roots problem, but S2 will flip, and therefore solution set for S2, whatever we have shown here. What is our S2? S2 was to the right of 0. Now it is to the left of 0. So practically, let me draw three solution sets here. First solution set is here, which is in black, S1. S2 is in red. This is 0. It is in blue, and left of this. So what is the intersection of S1 and S2? This part. Okay. Is it right? Huh. And S3 is, where is our S3? Minus 1 by 4 to the right. So the question remains whether minus 1 by 4 is to the left of 8 minus root 68. So if it is to the left, then minus 1 by 4, suppose is sitting here with hollow circle. Undo. And then hollow circle minus 1 by 4 and then points between them. Then this is going to be solution set inclusive 8 minus root 68. Are you there? Samajhte? So, but if minus 1 by 4 is to the right of 8 minus root 68, then what will happen? What will be the solution set? Then minus infinity to minus 8 minus root 68 closed interval. This will be solution set. Okay, so either this answer or minus 1 by 4 comma 8 minus root 68 closed interval. This answer, one of the two will survive. So therefore the question boils down to comparing minus 1 by 4 with 8 minus root 68. Take the difference. So 8 minus root 68 minus minus 1/4, that is plus 1/4, is equal to making this 33 by 4 minus 2 root 17. 33 by 4 minus 8 root 17 by 4. Okay, so denominator is gone. Now compare numerator. Numerator, square of 33 is 1089. So I can write 33 as root of 1089 minus 64 into 17 is 1088, root of 1088. Now we see that this difference is greater than 0. Therefore, minus 1 by 4 is less than 8 minus root 68. Therefore, the final solution set is this. Okay. So we have just started discussing quadratic equations and their condition. We will not get into very detail. We have to study something in 11th standard also. But at the moment we are stopping because it is 9 o'clock. We will solve this kind of problem in the next lecture by putting some other conditions on the roots and derive formula for what will be our general solution. Okay. Now you have on 17th you have PRMO, RMO. I mean, in the entire country, there will be hardly any students of your age having got this kind of training. Let me stop.